Hello everybody and welcome back to more of the 2010 Hypatia contest. We're looking at question number 3, so we're almost out of the woods. Just question 3 and question 4 to go. We finished up question 2 in the last video, so go back and check that out if that's the one you're looking for. But question 3, so we got a picture here. That's something that immediately draws our eye. In the diagram, square ABCD has a side length of 4. And ABE is equilateral. Okay, so AB, and then we've dropped this E down here. So it also has side lengths 4. Line segments BE and AC intersect at P. Alright, so we're talking about a point of intersection. Something that I'm starting to think is, maybe adding some coordinates on here wouldn't be so bad. Because if I can figure out equations for AC and BE, then it would be very quick to find their intersection. Point Q is on BC, so that PQ is perpendicular to BC and PQ. Okay. And PQ is equal to X. Alright. So, something else I'm noticing, BPC is a triangle, and we've got a height of X and a base of BC here. So, things to think about. Okay, determine the measures of the angles of triangle BPC. Okay, so now I'm a little, starting not to think that I should be using coordinates, just because they're talking about angles, and the Cartesian plane tend not to mix really well. I mean, you can have it, but in terms of angles of lines and then slopes of those lines, you have to. It's not always common knowledge that you're going to have y equals tan theta x plus b if your line is going off at an angle of theta degrees, so or theta radians. But so the fact that they started off with angles tells me I'm probably not going to want to throw a coordinate system on here. Now maybe that'll help. Maybe you're really good at that sort of stuff, but I think we can get by without it. So we want the angles here. Well, let's draw ourselves a copy of this picture. That's a terrible way to start that question off. Come on. We can do better. There we go. Much better. Getting worse, but there it is. So we have a nice big diagram, and we have an equilateral triangle here. And we have a nice big diagonal here. And this intersection point P here. Okay, and it's A, B, C, D, and then we also have X and Q and E down here. Okay, so we want some angles. Well, angles ABC and angle BCD are 90 degrees. Okay, they're 90 degrees right here. That's a nice, obvious statement. You can also say because it's equilateral, we know that angle EBA is 60 degrees. And of course, you can write a sentence, this is equilateral. I'm just verbally saying it. So we get 60 degrees here. Well, then that tells me angle PBC, which is angle ABC minus angle EBA, 90 minus 60, we get 30 degrees. Okay, so we have now calculated 30 degrees here. And we can do the same sort of thing. We know that angle ACD is going to be 45 degrees. How do we know that? Well, equilateral triangle, we've got a right angle here. So if you needed to write up that part of an explanation, go ahead. But I'm not going to write that out as a sentence. I mean, I would if I thought that these were difficult angles to understand. But notice that we've got A, B, C, and D. At most, this is going to be worth 2 marks. Okay, so probably 1 mark for PBC, 1 mark for PCB, and then you don't get another mark for the third angle because it's going to be really obvious at that point. So ACD is 45, so PCB is angle BCD minus angle ACD, 90 degrees minus 45 degrees, so we get 45 degrees. And then you could say sum of angles in a triangle is 180 degrees. Well, we've got 30 degrees, we've got 45 degrees, so we've got 75 degrees on offer. So angle BPC is got to be 105 degrees. And you could also say, well, it's 60 from this right angle triangle and 45 from this right angle triangle. That's another way to see it, but there you go. So maybe just put a box around each of them, or maybe make a final statement, but we've got all the angles in BPC. Okay. D part. Find an expression for the length BQ in terms of x. Okay. So, what sort of expression would we have? Well, it's a little vague. I'm not going to lie on that one. But it's grade 11 contest, so I think we could very quickly snatch this up with some trigonometry. So, BPQ is a 30 degree, 60 degree, 90 degree, or 30, 60, 90 triangle, as we often call them. So, and you could say, well, it's 60 degrees and we got a right angle, so, tan is opposite over adjacent, so, this is going to be tan of 60 degrees times x. That would be perfectly fine to say as well. Use some trig that way. But 30, 60, 90 triangles are incredibly common. Incredibly common. So, the sides have a ratio 1 to root 3 to 2. Thus, BQ is going to be root 3 times x. The shortest side is x, then we get root 3x, then we get 2 times x. And this would be fine. You could also do it the trig way, as I said, some sines, some cosines, some tans, however you want to play around with that. But that would be perfectly acceptable as well. Not a whole lot going in this B part. Okay, trig or 30, 60, 90 triangles. And that's actually kind of interesting. Put a root 3x here, because we're going to get an x here, thanks to isosceles triangles. And now we have an equation for BC in terms of x, but we know BC has side length 4. Nifty stuff, nifty stuff. I don't know if that's where we're going, but there it is. Determine the exact value of C. Well, there it is. So we'll do this on the next page, but you might also say, well, PQC is isosceles because it's a 45, 45, 90 triangle. So CQ is equal to X. Now I know 4 is equal to BC, which is equal to BQ plus QC, which is equal to root 3 X plus X, which is 1 plus root 3 times x. So x is going to be 4 over 1 plus root 3, and you would be well within your rights to leave it like that. However, if you're a little older or you go to a private school or a more strict school, they'll say, no, you can't leave it like that. You have to rationalize the denominator, so we're just going to really quickly rationalize the denominator. Multiply by 1 plus root 3 there. No, this one's plus, so these guys have to be minus. I knew something was wrong. Well, we'll make it root 3 minus 1. That way we don't have negative numbers anywhere in our expression. So we'll get 4 root 3 minus 4 on top, and we will get root 3 minus 1. So we'll get 3 minus 1. So there's going to be a 2. So it's going to be 2 root 3 minus 2. That's our expression there. Okay. So that gives us our value for x, and yeah. So we still have C part to do. That's what we got to do. C part. Determine the exact value of x. We did that. We've got two expressions for it actually. Determine the exact area of triangle APE. So this leftover bit. Interesting. Okay, I think I'm going to have to redraw my picture here. Alright, so we want this little sliver here. Okay, that's what we want. We want A, P, E, B, C, D, and then we've got this X here. Okay, so we want this area here. Well, that's this big blue right angle triangle minus this sort of yellowy area. So if I knew the area of the big blue triangle, which I probably can figure out because it's got a side length of 4, it's equilateral, and I knew this yellow area, well, then I can just take the difference there. That'd be fine. So the question now shifts, how do I get to that yellow area? Well, let's look at this big purple triangle. It's a nice isosceles right angle triangle, base and height of 4. No problems there. And the yellow area is just the area of the big purple triangle minus this orange area. Well, this orange area is BPC, which has a height of x and a base of 4, and we just figured out what x is. So, let's write this down. APE is ABE minus APB, and then APB is triangle ABC minus triangle BPC. Now I don't actually need to work out this yellow area, this APB, because now I can combine these two. The area of APE, the thing I want, is ABE, an equilateral triangle, minus ABC, and then minus negative PBC, so plus BPC. And these are areas I can work out now. Okay, so triangle ABC, 1/2 base times height. Well, it's going to be 1/2 4 times 4. So it's going to be 8. Not a whole lot to say there. I mean, if you needed to, say it's a right angle triangle and side lengths are 4, you know, that's fine. Now, BPC, 1/2 base times height, well, that's going to be 1/2 x times 4. And that's going to be 1/2 2 root 2 minus 2 times 4. The 2's will cancel out, so we'll get 4 root 3 minus 4. That's that area. Okay. Just making sure I calculated that all out. Yep. Okay, and now the slightly harder one, ABE, that equilateral triangle. So I'll show a little bit more work because not everyone has the formula for an equilateral triangle memorized. It also has a nice 30, 60, 90 triangle in it. So we got 4s, we got a big 4. Because the base splits quite nicely with 2 there, we've got a 30, 60, 90 triangle here. So the height is going to just be 2 root 3. So if you do know the formula in terms of the side length, it's S, and then the height is S over 2 root 3 all over 2. So it's root 3 over 4 S squared is the formula. And if you said that, you probably would be fine. I can't see them particularly taking marks off because you say, here's the equilateral triangle formula, and it's quite obvious to me. I don't think anyone's really going to ding you as long as you use the formula properly. But, you know, if you need to, here's a picture. Shows how we can calculate it, 30, 60, 90, or just use trig. There's a height of 2 root 3, and a base of 4. So its area is 1/2 base times height. So it's going to be 4 root 3. So triangle APE has area equal to, well, it's this one, 4 root 3, minus ABC, which was 8, plus 4 root 3 minus 4, if I'm remembering that correctly. Okay, 4 root 3 minus 4. So it's ABE minus ABC plus PBC. But then this is 8 root 3 minus 12. Now, just as a little sort of sanity check, we're ladder calculators, I'm just going to make sure this is a positive area. Okay? Does this tell me whether or not I got it right? No, but it would be a really glaring error if I got a negative area. So we want to avoid that. So 8 root 3 is 13.8, so we'll get minus 12, so 1.8, a little less than 2. 1.85 is the area. And, you know, does that make sense? Well, you know, go back and look at the picture. Yeah, you know, I guess so. It's kind of hard to judge, but the whole thing is 16, and this is just a little sliver. It's the portion of half of it, which is 8. I'm inclined to believe that, and the math certainly works out. The point is, if I had gotten something like, oh, the area, 4 root 3 minus 12, or sorry, 8 root 3 minus 12 happens to be negative 2.7, I would say, okay, I did something wrong. Either I calculated an area or some areas wrong, or my equation to get APE as, this triangle minus this triangle plus another triangle minus the, maybe my reasoning for that was wrong. Okay, but just a quick check at the end, because if I'd done something, it's certainly possible I could have calculated a negative area. I didn't. I'm confident in my work, so I'm going to go with that. My exact area, and the fact that they asked for exact area kind of implies that we should probably have some root 2s or root 3s or something in there. So 8 root 3 minus 12, everything worked out there, and that gave us the answer for D. So, in the next video, we're going to wrap the Hypatia up with question number 4, which looks a little short, but we'll dive into that next time. But that's question 3 there. Hopefully you guys enjoyed it, and I will see you all in the next video. Thanks for watching.